Uh, oh, they won. Yeah, that makes sense. Okay, that's okay. That makes sense. Let me back up a little bit. Let's see who else. Okay. All right. Share my screen. All right. Oh, okay. All right, gentlemen. So welcome. No real announcements. We're just doing a homework session for section 1.5. Yeah. So my earlier class, we were able to finish all the questions. So I'm going to try to do the same thing here. As usual, if you have questions, feel free to either unmute yourself or type in the chat or the Q&A. Matter of fact, let me open this up so that I can monitor. Join.
Of situations from the business, and it ultimately led to free.
Okay. I always forget to do that. Let me just start it over. Turn off the video. Don't connect audio. Okay. Stay as a participant. Okay. So again, I think we can get through all the questions we were able to earlier. So I'm going to start here. I'm going to try to get through all the questions. Okay. So this first question comes from section 1.5. This question 1. Describe the transformations. Okay, so I'm curious as to what you all think, right? Let me see. The parent function here is a square root function. So keep in mind that image is the top half of a sideways parabola. And then basically it's asking, how does this transformation, or what effect does this transformation have, right? So we added 2 on the outside. We got a couple that answered. Let me see. Plus 2 on the outside. Okay, I'm going to submit the results. Take a few more seconds. That's enough. Okay. So the poll is closed. I'm going to go with the majority here. So plus 2 on the outside should move the entire graph up 2 units. To relaunch. So if you got the first one, then the second one should be pretty straightforward. We're saying -4 on the outside. Is that gonna, let me see, I'm just gonna kind of go quickly here. Okay, so that -4 is on the outside. Okay. Take a few more seconds here. Okay. All right. So I'm gonna go with this results. Should go down by 4 units, right? So Outside manipulations generally cause a vertical change. Inside manipulations cause a horizontal change and are typically the reverse of our intuition. Let me say that one more time. Outside manipulations generally cause a vertical change, and they typically follow our intuition. Inside manipulations typically cause a horizontal change and are generally the reverse of our intuition. Okay. Can we just go to the next question? Describe the transformations. Okay, so more transformations. We're going to relaunch the poll. Let me see. So our parent function is really absolute value of x, but our original function is absolute value of 8x. So then for part A, if we multiply the outside by a negative, right, how is that going to affect the graph? Is it going to cause a horizontal stretch by a factor of 8, reflect across the x-axis, cause a vertical stretch by a factor of 8, reflect across the y-axis? Okay. So I'm going to go with my results. Okay. All right. So you guys are looking good. I agree with the majority here. So outside manipulation should cause a vertical change. It's like our y values are going from positive y to negative y, so it should flip vertically over the x-axis. Let's submit that. Okay, relaunch. Okay. So next one, we're multiplying the inside by a negative. Does it A, reflect over the y-axis, B, reflect over the x-axis, C, cause a vertical stretch by a factor of 8, or D, horizontal stretch by a factor of 8? We're going to take a few more seconds, and I'm going to trust you guys, and I'm just going to go with the majority here. I'm going to go with the majority. Okay. A few more. The others? Once, going twice. Okay. So majority is saying C. Ooh, it's close. Ooh, let me see. Let me think about it. C is not correct. Vertical stretch by a factor 8, no. Reflect, yeah, it should be A, right? So I had a few people, I was gonna go with the majority, but I looked at it, I was like, oh, that's not the right answer. Right? So multiplying the outside causes it to flip vertically, multiplying the inside causes it to flip horizontally, right? Okay, that's fine. Okay, I gotta do my little setup like I had earlier. Oh. So I had a realization. Basically what happens, essentially, generally speaking, I'm like, fine, I kind of got my energy or whatever. And then as soon as I sit down in the chair, after about 5 minutes, I'm looking down at the screen, my head starts to go down. I want to put my head down and I want to go to sleep. So I was like, so what I did earlier, I set the I set it like a timer.
Are you trying to look at me in his face? Yeah, I'm trying to see. Maybe a bit closer to you.
It's okay. I set it up on a tower just to like give myself energy. So I was like, if I get up, I look up, the body goes with wherever the head goes, the body will follow. Wherever the eyes go, the head will follow. Right. So if I can look up, I can get my head up, get my energy up, and I'll be up. Right. Okay. Describe how the graph of the following function can be obtained from one of the basic graphs. So we have the reciprocal function, and we multiplied it by 5. So that's like multiplying. We have 5 over x. So in this form, this is similar to multiplying the outside of our base function by a number larger than 1. So outside manipulations generally cause a vertical change. And then inside manipulations cause horizontal. So start with y equals, so the parent function here is going to be the reciprocal function, which is 1 over x. If we're multiplying the outside by a number larger than 1, that should cause a vertical stretch by a factor. So we want to stretch it vertically by multiplying each y coordinate by 5. Okay. I feel like that one wasn't too terribly bad. Here we're asked to graph this function. So the parent function here is y equals x squared, which is a parabola, a U-shaped curve. And then we subtracted 7 on the outside. So that all that's going to do is take the entire graph and move it down 7 units. So I'm going to click on my parabola tool, which is upper right in this case. I'm clicking randomly on the curve. And then we said we're just going to move it down by 7 units. So I'm going to do a vertical shift of -7. I think that's the only manipulation. I'm gonna hit save. Okay, and check. We are moving and grooving. I'm a little nervous. We might actually get to this too quickly, but that's okay. You know, we might call it an early day if that's the case. Graph the following function. Okay, so we have the square root function. I think you guys can do this one. I'm going to relaunch the poll. I might go. I'm tempted to go with the majority. You guys make me nervous. If we get these wrong, it's just going to make it, delay everything, right? So we just launched the poll. Let me make it so you can see this guy. So we have the square root of x, and that +4 is on the outside of our base function, right? So how is that going to affect the graph? Should it be A, move it to the right 4 units, B, move it up 4 units, C, move it left 4 units, or D, move it down 4 units? Okay, just take a moment. Okay, going once, going twice. In this, come on. Mute. All right, so I think I can relaunch it. It should be here. Okay, oh no. I don't want to relaunch it. Can I just show what we have? I didn't realize that was going to happen. Okay, that's fine. But I think everybody had put B, so I'm just going to go with that. Cool. On to the next one. So we're like breezing things, right? Okay, transformation. So we're going to relaunch the poll. Okay. Use transformations to graph the following function. So our parent function here is absolute value of x. We added 5 on the inside, right? So +5, we'll see some conflicting results here, right? So +5 on the inside, will that move the graph to the left 5 units? Will it move it down 5 units as in B? Will it move it right 5 units as in C? Or will it move it up 5 units as in D? What do you think? Okay. Interesting. Interesting. Okay, so poll is closed. X +5 inside manipulation should cause a horizontal change and are typically the reverse of our intuition. So that means it should move side to side. Intuitively, we might be tempted to go right 5 units, which is the positive X direction. But again, inside is the reverse of our intuition, so it should be A, move it left 5 units. Okay. Man, I might be going too fast. We are like breezing through these, right? Graph the following by starting with the function from the library. Okay. So we have multiple transformations in one go. I might have to suppress that for it to work. Yeah, I'll just suppress it for now. That's okay. Okay. All right. So we can kind of see the graph on the left. So the base function is x squared. So I'm going to click on my x squared tool. I'm just going to click randomly on the graph. So here's one. Okay, this menu popped up, right? So we're starting with a parabola with the vertex at the origin. And the suggestion is whenever we're doing multiple transformations in one function, the order in which you want to do these guys, you want to start work your way from the innermost nested transformation and work your way out. So the innermost nested transformation here is the -3 on the inside, right? So it should move it to the right 3 units. So I'm going to say horizontal shift. I'm going to drag this to a +3. Okay. And then the only other transformation is the +4 on the outside. That should move the entire graph up by 4. Okay, so hopefully, so again, all we did, we started with a U-shaped curve at the origin, with the vertex at the origin. We just went right 3 and up 4, and then that was it. Hit save and check. Okay. And I want to say this is going much faster than my earlier group, but that's okay. Graph the function using techniques of shifting. Okay, another graphing. So the parent function here looks like it's x cubed. X cubed is going to be third row on the left. I'm going to click on that tool. I'm just going to click randomly on the graph. Okay. So I see two transformations. The first one that I would tackle is that negative. It's essentially on the outside, so it should flip it vertically over the x-axis, and then vertical shift, we want to move it up by 12. Okay, and check. Next. I might be moving too fast, but it'll be okay. So we're almost already halfway. Okay, more transformations. So the graph, let's click on the graph. Okay. So the parent function here looks like it's what? X squared, which is a parabola. Okay. It looks like we're going to plot multiple points. So I'm just going to click on two random spots on the graph. Okay. So let's see. First thing I'm going to do is track the vertex. So normally the quadratic starts at the origin. We have a total of 1, 2, 3, 4 transformations at play here. If I use the coordinates of the vertex, so in this form, this is like the standard form of a quadratic. So it automatically tells us the coordinates of the vertex. This is saying that the coordinates of the vertex, we will go left 3 and down 3. So the vertex should be -3, -3 right there. Okay. And then for something like this, honestly, just a second point is all you really need. So if the vertex occurs when x is -3, I'm just gonna find when x is -2 and find the corresponding y. I just went to the right by 1, or I just went to either side by 1, right? So if x is -2, plus 3 is gonna give us 1, squared is 1, times -3 is -3, and then -3 is gonna be a -6. So we should be at -2, -6 for that second point. Okay. So this example, we were able to like drag or move our points retroactively, and we get an image like this. Notice that we have a negative leading coefficient. Our parabola is open downward. We went left 3, down 3, and I think we're good to go. Hit save, check. I really might be moving too fast. Go to the next question. Okay. All right, so this one, our parent function is f of x equals the absolute value of x. And then using transformations, if we use transformations, if we start with the absolute value of x, how do we generate, what is g going to be? Is it going to be A, B, C, or D, right? So just take a moment. I'll give you like maybe 20 more seconds. The poll is active. I see multiple answers going. Okay. I want you to take a few more. Okay. Let's take 20 more seconds. Watching the clock. Watching the clock, counting up. I was about to say is counting down. Still got 10. I'm so sleepy. 10. Okay, that's enough. I don't feel like waiting 10 more seconds. Okay, that's enough. Okay, so majority of people think it's A. Interesting. I got a few for B and C. Let's talk about these transformations, right? So if we're starting with absolute value, normally, absolute value is a V with the vertex at the origin. The first transformation that we would consider is that +1 on the inside. So that would move the V to the left by 1, okay? Then we multiply the outside by a negative. So that's going to flip it from up to down. So we know we went left 1 and it's upside down. So it can't be B or C. So we can eliminate those two because they're opening in the wrong direction. And I think that D looks like it went to the right. So by process of elimination, it should be A. I agree with the majority here. Check. Just watch. I did not like season 7 at all. This latest season of the circle, I did not like it, and I was like, I was so mad. I was so angry. Anyway, even like if you have been watching it, I'm not gonna spoil the finale, but I just didn't like that. Like the people that I were rooting for all got booted. I was like, man, I was like, ugh. Anyway, that was a wild ride. I mean, it's a game show. You gotta, only do what you can do. I don't know if they're gonna do another season here in the city. I know over the weekend I drove past the building. I was like, oh, there it is. I thought I could walk there from on my route, but it wasn't near, so I drove past it a little bit later. So it was cool. Okay, so this is the greatest integer function, right? We call this a step function because when it's done, when you graph it, it looks like the steps on a staircase. So the greatest integer, whenever like you take the greatest, whenever they give you an integer, you just take the integer. And then if they give you a number between two integers, then you're going to take the integer to the left, right? So if they give you any decimal or fraction between two integers, you got to decide, okay, what's the integer on the left? What's the integer on the right? And then you take the integer on the left, okay? So normally, greatest integer function, it's filled in. It's a filled-in circle at the origin, and it's a segment going off to the right. And then when it gets to 1, it's an open circle. Then it jumps up, right? Okay. So then if we consider, let me relaunch this poll. I'm just curious what you all think. Relaunch. Okay. So we have two transformations at play here. First, we did a +3 on the inside, and we multiplied the outside by 2. Just take a moment. What do you think? How do you think that's going to affect it? So again, I'll at least describe the original graph. So the original graph of the step function is a filled-in circle at the origin. It's a solid bar going to the right, and then once x reaches 1, there's an open circle, and then it jumps up to the point 1, 1. The point 1, 1 is a filled-in circle. Then the step kind of goes up to the right. Once it reaches 2, it's an open circle. Then it jumps up, and it's a filled-in circle at 2, 2. And it kind of continues that path in both directions, right? So with that, okay, let me see. I think I'm going to close the poll. Okay, you guys make me nervous. I'm going to challenge the majority in this one, right? So normally the filled-in circle is at the origin. So you could track that, right? If we do a +3 on the inside, it should be a horizontal change. It should move it left. It should move it left by 3, right? And then we multiply the outside by 2 by a number larger than 1. So it should cause a vertical stretch by a factor of 2. So it can't be C or D because those are vertical compressions. Those were smushed, so we can't eliminate those. The problem with A, it looks like A went to the right where it should have gone to the left. That might be a little bit challenging to see if you don't understand like the original graph of the greatest integer function. I'm going to challenge the majority and say that the answer is B. Yeah. Okay. So that one is a little bit tricky because it's an unorthodox function, right? 222. Write the function whose graph is absolute value of x but shifted to the right by 9 units. Okay, let's take some notes here. Well, not really take notes, but we're going to write here. Off. Okay, where's my keyboard? Oh, okay. So let's start with the absolute value of x. I'm just going to do like, if I can get this working. Are you acting up? Okay. So let's start with the absolute value of x. It says shifted to the right by 9 units. So to the right is the positive x. So that's a side to side. So that means we need to be working on the inside. It's tempting to say +9, but remember inside is the reverse of our intuition. So it should be -9 on the inside. I'm going to hit enter. Okay. Next question. Okay, let's relaunch the poll. So write an equation for a function that has a graph with the given characteristics. It's the shape of y equals x squared, but it's upside down and shifted right 8 units and up 5 units. So let's just take a moment. I'm just curious what you all think. Hey, Google, play some non-copywritten game show music. No. Let me see what she does. She heard the no. Okay, I see some choices. Hey, Google, play some non-copywritten music.
Sure. Here's a YouTube music playlist called Cool Non-Copyrighted Music.
Let's take like a few more seconds. Oh, I'm not feeling this one. I'm gonna let it ride. It has a Mario feel to it. Okay. Hey, Google, stop. Okay. All right. Let me think. Let's see. Upside down. We said right 8. Okay. 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 I'm gonna close the poll. I think I am gonna go with the majority here. Feels like Who Wants to Be a Millionaire? Is it so? D, is that your final answer? Lock in that answer. Let's see. Nice. Okay. Okay. Good. So it's not. I feel like majority for the most part is okay. Guys, that makes me feel a lot better. Okay. Let's look at this one. Write an equation for a function whose graph fits the description below. It's a cube function shifted 3 units left. Okay. So before I go through all of that, I am going to start here. And I'm going to do my x cubed, but I'm going to put it in parentheses like this, okay? And then I'm going to try to account for each manipulation as they arise. So it says shifted 3 units left. So side to side means we need to be inside the base function, so inside the parentheses. If we're going to go 3 units left, that means we need to add 3 on the inside. So we're going to say plus 3, okay? Stretch vertically. So vertically means we need to be on the outside of the base function by a factor of 2. It follows our intuition, so we're going to put a 2 on the outside. Reflected horizontally, so side to side, so that's an inside manipulation. So I'm going to replace x with negative x. That's all I'm going to do there. And then shift it 5 units up, okay? So that's an outside manipulation. We're going to say plus 5 on the outside, okay? And I'm just going to hit enter. Nice, okay? All right, we're moving and grooving. Let's see. That was 13. Okay. I think we can do it. We're in track. Okay, let's relaunch the poll. Yeah, getting up definitely helps. And I got this idea to get up. Well, I guess I should have gotten it from the teaching, back when I used to do teaching in person. The weird thing about this being remote, I was already planning to be remote before the pandemic. Like a part of me, because the original vision was I can be in some place like Hawaii or someplace like a tropical island or someplace like that. Like, okay, guys, I'll see you next time, and then boom, shut the thing, and then I'm already someplace tropical, right? So half of the thing is already there, and then next thing you know, this pandemic, and we were forced. So I guess that was my intuition, like, hey, you need to be ready to do this. And then hopefully everybody's safe, because I know there was a lot of chaos in North Carolina with the flooding, and then I know there was a chemical explosion, a chemical fire here in Atlanta. And then I think there were a few other fires around the states as well, not too far spread apart. So I don't think any of this stuff is accidental, because it just seems like our quote unquote leaders are out to take people out, because it really does not seem like they have it does not seem like they have our best interest in heart. The thing that really grinds my gears is they're so willing to give money to illegal immigrants, to Israel, and to Ukraine, but they ain't got nothing for the people that's been here, working everything. This has been my qualm with this election. I'm like, you guys have had access for 4 years, and you keep crapping on us. So I'm like, I don't really care, personally, because I'm not trying to continue what's going on, and I struggle to back the other guy too. So I'm just like, anywho. Okay. So, but yeah, so I got the idea to stand up from gaming, actually. When I'm gaming, sometimes I was like, I don't want to sit down anymore, but I want to keep gaming. So I set up a little tower, stand up, and game for a little bit. Okay. So we're given this y equals f of x. Now we got a +1 on the outside. Okay. All right. I think I'm gonna go with the majority here. So +1 on the outside should move the original graph up by 1 unit. And you can kind of like track the center, like the part that's at the origin. So the only one that moved up was part A. All right. So we're gonna go with A there. Okay. Okay. We're getting some feedback. Let's do another one. Relaunch. I'll give you like some time. Hey Google, play some non-copywritten gaming music.
Okay, playing no copyright gaming music on YouTube Music.
I'm gonna let this one ride. Hey Google, pause. So if you were watching this season 7 of The Circle, this one character, I was like, is this real? Is like this really their voice? Hey yo, hey, I'm walking here. I was like, yo, is that a real thing? I mean, I knew it was. I thought it was all like satire. And I don't. It's just kind of throwing me for a loop to see people actually like that. And they kept that like energy up the entire time. I was like, man, I don't know if I could do it with a straight face. But yeah, anyway, hey Google, play. We'll take a few more seconds. Okay. Let me see. Oh, I guess it didn't hear me. That's fine. Okay. Let me kind of chat about this before I close the poll. So the original function f of x is given on the left, and then the manipulation is they multiply the inside by a number between 0 and 1, right? So multiplying on the inside should affect the graph horizontally, and it should be the reverse of our intuition. So this is a small number. Intuitively, you might be tempted to say, oh, it should get smaller horizontally, but in reality, it's going to do the reverse. So this is actually going to get bigger horizontally, right? So I'm going to close the poll, right? So it should actually cause a horizontal stretch by a factor of 2, which I think is actually C. I'm going to go with C on this one, right? Those inside manipulations are tricky. They are tricky. They're tricky. Don't stop. Anyway, thinking of like White Chicks with the Wayans brothers. Okay, let's relaunch. Okay, let's try another one. So the original function is given. I'm going to give you some time. Hey Google, play some non-copywritten gaming music.
Sure, here's a YouTube Music playlist called Gaming Music No Copyright.
Oh my God, just put this on. let's take it anywhere from 10 to 20 more seconds. This one's okay. A couple more seconds. It's taking too long to develop. Looking at this question, gonna go real hard, gonna go fast. What you think? Get out of almost. Oh, I'm liking this. I can see this one. This one has potential. Whoa. I can see like Goku going at it, like, you know. Oh. Hey Google, stop. All right. Hey Google, stop. There we go. All right, so let's close the poll. All right. So we subtracted 4 on the inside. I think the majority is wrong in this case. Subtracting 4 on the inside should move it side to side. It should go to the right by 4. So one person saw it. That's why I started stalling. I started to go with it. I was like, wait a minute. And I stalled, and one person picked it up. If I was given extra credit, only one person would get it in that case. I'm not officially doing it yet. Not yet. But yeah. But it's okay. I mean, you know, I'm leaving it anonymous for the most part. Relaunch. I could start giving extra credit at any moment. You never know when I will and won't do it. If I'm gonna do it at all. All right. So let's see. Could do that. Anyway, so we got this graph that's given. We have multiple transformations in one go. Okay. So just I want to give you some time to see if you can get it correct here. Right. Hey Google, play. Let's just take some time. Maybe 30 seconds. Oh, so now to me, this sounds like the Matrix club scene. They're all like in slow motion. Yeah, you know, like jumping, dreads are flying everywhere. But they got on like pleather. This isn't the Earth one where they're in Zion. This is like they're in one of those clubs. Okay. Hey, Google, stop. Okay, so let's see what we're working with. I'll leave the poll open for a little bit longer while we kind of talk about it, right? So with something like this, it might be easiest to track maybe that point at the origin or that peak. I'm thinking I'm going to track the origin, right? So let's talk about these transformations. Again, the recommendation is to work our way from the inside to the out. So the innermost nested transformation is that -1. So if we track the origin, it should go right by 1. Okay, it looks like they all kind of went to the right by 1, so that doesn't help us. So the next one that we want to consider is the 1/2. We multiplied the outside by 1/2. That's gonna cause a vertical change and follow our intuition. So it should cause a vertical compression by a factor of 1/2. So it should get smushed. Okay, so I think that eliminates C. C doesn't look like it was vertically compressed, right? So I'm going to eliminate C. Yeah. So it should be either A, B, or D. And then we multiply the outside by a negative. So that's like our Y values. We're going to go from positive Y to negative Y. So it can't be D. So I think we can eliminate C and D. I'm going to go ahead and close the poll. Okay, we can eliminate C and D. And then we went up by 3. So the only one that did all of that, it looks like is B, because it looks like A did not move up and down. And again, Lone Ranger, all right? Okay, let's go with B. Okay. Oh, let's keep going. All right. So let F be a function that associates the employee number X of each employee in a corporation with his or her annual salary, F of X in dollars. Suppose each employee was awarded a $200 across-the-board raise and an additional 3% of his or her increased salary. Write a function P of X to describe the new salary, okay? So if their original salary is F of X, I'm going to take some notes here if I can get it working. So the original salary is F of X. Tangent, random tangent, just because it popped in my mind. So I don't know, like this time of the year, this is October, so we're approaching like Halloween. So I've realized that like there are certain shows I like to watch as I approach different holidays. Like going towards Halloween, I like to watch like Coco, Soul, The Book of Life, and like things that are like creepy. And so the one that just popped in my head now is a show. When it first came on, I mean it was a lot of fun. On Netflix, it's called Prank Encounters, and like it's fun. It's like it's basically a prank show, but they have like really silly like pranks where there's zombies and people are freaking out. And like I'm like, come on, you really think this is real? Like, but it was so funny. It was so funny. I think they only have like 2 seasons, so it would be nice if they did more seasons. I mean, that would be a lot of fun. It would be even more fun to actually be on the show. I always kind of think about being on these shows. The main show I really would like to be on is The Amazing Race. That one looks intense. I think I'm going to apply anyway. Okay, so back to this. That was a fun little tangent, right? So we have their salaries. Then it says each employee is awarded a $200 across the board raise in their salary. So we're going to take their salary and add $200. I'm going to say plus 200. Another good movie is both Haunted Mansions. The one with Eddie Murphy is the first one, and then the second one with like Tiffany Haddish and the guy from Atlanta. I can never remember his name, but I like them both. And they kind of are fitting for this time of year. Coco, Soul, these kind of things. Let's see, and then an additional 3% increase on the increased salary. So we've already increased their salary once, and then we're going to increase it again by an additional 3%. So what we have shown on the screen right now could be considered like 100%. We want to take this and increase it by 3%. So 100% plus 3%, they should finish with 103%. So if we write that as a decimal, that would be 1.03. So all I'm going to do is take this number that's shown right now and multiply it by 1.03. Okay. I'm going to go here we're going to put 1.03, and we need to distribute it. Distribute it across the board, okay? I think that captures the flat raise along with the 3% increase on a new salary. So then we do need to simplify this guy. So if we distribute that 1.03, we're going to get 1.03 times f of x. Now we need to calculate, we need to 1.03 times 200. 10% of 200 would be 20. 1% would be 2. So then 3% would be what, 6? So 206. So plus 206. Let's get rid of these notes. Okay, we'll go with this. What's the time? Oh, we got 5 minutes left on the clock. Party's almost over. What a bummer. We're gonna wrap up. I guess I stalled too much. Oh, nice. That looks really good. Okay. Come on. All right. How many more? Oh, we're almost there. We got 2 questions. Let's try to wrap this up. Okay, so in the given graph, the temperature of a home is given as a function of time. At what temperature is the thermostat set during daytime hours? So during the daytime, if that's 64 and that's 68, halfway would be 66. So it's just below that line. So I'm going to put 65. I'm going to put 65 degrees. Okay. The thermostat is set to what degrees overnight? If that's 52 and that's 48, then the halfway will be 50. So I'm going to put 50. Wait a minute. I'm going to put 51. All right, 51. I almost put 53. Okay. The homeowner reprograms the thermostat to T of T minus 6, right? So notice that minus 6 is outside our base function. That's going to drop the whole thing down by 6 degrees. So not earlier or later, lower the temperature by 6 degrees, right? We're going to drop by 6. So instead of that being 65, it should be like 59. I think that's D. Yeah, let's just go with D. Just the time. Okay. So then if we say plus 4 on the inside, that's going to move it to the left by 4 units. So that's going to be 4 hours earlier. Okay. And 4 hours earlier, let me see, what time is that? I don't even know. Those are about 2, so that's 8. So that's a 7, so about 3. Okay, I see it. I think it's A. Let's go with A. So basically, we're just trying to choose the one that moved the graph to the left by 4 hours. Got one more? Oh, that was it? We did it. All right, guys, that was perfect timing, all right? Are there any burning questions before we go our separate ways? So we didn't really need to write anything, okay? So if there aren't any burning questions, we're gonna go ahead and end the session here. From one beautiful mind to another. Have a great weekend, gentlemen. And on Monday, we're gonna start the next section, I think it's section 1.6. That'll be the last section before exam 2. All right, guys, have a great weekend. I'll see you next week, same time, same place. Take care, peace. Hey, Google, play. Oh. All right. Let me go back to the right section. All right, greetings, scholars. So what we're going to be doing today is just going through the homework for section 1.5. With my early two groups, we were able to get through all the questions. So we're going to just try something similar here. Hope everyone is doing well. All right, so let's see. Okay, so let me go ahead and launch the poll. All right, so in this first part, we have a square root function, right? And for part A, we want to say, okay, if we add 5 on the outside of the square root function or on the outside of our parent function, how does it affect the graph? Does it shift it 5 units up, 5 units down, 5 units to the right, or 5 units to the left, right? Okay. So I think I'm going to close the poll here. And I'm going to go with A. I think A is a good one. Okay. Let me relaunch this. And then for B, we're subtracting 4 on the inside. On the outside. So then is that going to shift the original graph 4 units to the right? B, is it going to shift 4 units to the left? C, will it shift 4 units down? Or D, will it shift 4 units up? Just take a moment. We're subtracting 4 on the outside. Okay. So I think C is correct. Let me close this. All right. The next question. Okay, let's relaunch. So in this one, the given function is the absolute value of 6x. Okay, so for part A, if we multiply the outside by a negative, how does that affect our graph? Right, so just take a moment. Will it A, flip over the y-axis? Will it B, flip over the x-axis? Will it C, cause a horizontal stretch by a factor of 6? Or will it D, cause a vertical stretch by a factor of 6? Okay, again, the given function is the absolute value of 6x, and we're multiplying the outside by a negative. How is that going to affect our graph? Let's take a few more seconds. Okay, let's see. Okay. So outside manipulations generally cause a vertical change and they follow our intuition. Inside manipulations generally cause a horizontal change and are typically the reverse of our intuition. So I'm gonna end this poll. Let me see. Okay. So I'm thinking it's B. Reflect in the x-axis. Yeah. It should flip vertically over the x-axis. Okay. If we multiply the inside by a negative, it's going to flip horizontally over the y-axis. Okay. So to describe how the graph of the function can be obtained from the graph of our basic functions. So h of x is going to be 11 over x. So then we can start with the reciprocal function and multiply it on the outside by 11. Okay. So we're going to start with the reciprocal function. If we multiply the outside by 11, that's going to cause what? A vertical stretch by multiplying each y value by 11. Okay. All right, so this one we're asked to graph. I think, let me see, will that help us? Let me see if this will work. No. Almost. We're just going to suppress that for now. Okay. So the graph we have is y equals x squared minus 5. So then there we could say that the parent function is x squared, and we subtracted 5 on the outside. So x squared is a parabola. I'm just going to click randomly on the graph, okay? Put it at the origin. It put the vertex at the origin. Subtracting 5 on the outside of our base function should move it down by 5 units. So it should cause a vertical shift of -5 units. Okay. Okay. So graph the following function. So we have the, let me open the poll for this one. Relaunch. Okay. So here we have y equals the square root of x, and the +1 is on the outside of the parent function. So then which graph should be the correct graph? Will it A, move it left by 1, B, move it down by 1, C, move it up by 1, or D, move it to the right by 1? Okay. So again, let's do a recap. We have y equals the square root of x. That +1 is on the outside of our parent function. So will that cause it to move to the left by 1? Will it cause it to move B down by 1? Will it cause it to move C up by 1? Or D to the right by 1? Just curious. What do you guys think? Let's take a few more seconds, get some more people in here. Okay. So +1. Okay, I'm going to go with this result. Okay. All right. So give this one a go. Relaunch. All right. So again, like with my earlier group, we were able to get through all the questions. We are still moving at a pretty good pace, but the faster we can kind of get this going, the sooner we can leave. But we need to finish. Use the transformations of absolute value of x to graph the following function. So we have g of x is going to be the absolute value of x plus 5. So that +5, notice that is on the inside of our base function, right? So to recap, outside manipulations cause vertical changes, and they typically follow our intuition. Inside manipulations cause horizontal changes, and they're generally the reverse of our intuition. So we should be starting with the v at the origin. All right, I'm going to go ahead and close the poll. The vertex, so if that +5 is on the inside, it should move it to the left by 5 units. Oh, man. Oh. Okay, let's go to the next question. So that one should have gone left by 5, right? Okay, so for this one. So basically we're doing transformations in succession, so multiple transformations. The recommendation is when we do multiple transformations in one function, work your way from the inside to the out. Start with the innermost nested transformation and work your way to the outside. So if we have a parabola, U-shaped curve, I'm just going to click randomly on the graph. Okay, so I think I put the vertex of the parabola at the origin. So then the function on the left, the transformations, first one is we have this -1 on the inside. That should move our graph to the right by 1. So I'm going to drag this to the right by 1. Okay, and then we got a +3 on the outside, so it should move the entire graph up 3 units. Okay. Check. Oh, let me think. Right and up, maybe I didn't click it right. Oh, I only went up by 2. Supposed to be 3. Okay. Okay, so this is a similar deal. The parent function here looks like it's x cubed, which is third row on the left in this case. I'm just clicking randomly on the graph. So the first transformation I notice is we multiplied the outside by a negative. So that's going to flip it over the x-axis. And then we added 10 on the outside, so that's going to cause a vertical shift up by a factor of 10. Okay. Okay. So we're moving and grooving. Use transformations, okay. So let's enlarge. Let's see a parabola. I'm going to click randomly. Okay, I click on 2 random spaces. So we can move these points retroactively. So the parent function here is a parabola. The first transformation. So what we can do, typically the parabola starts with the vertex at the origin. So I'm going to start at the origin. That +1 on the inside is going to move the vertex left by 1. And then that +4 on the outside is going to move it up by 4. Okay, so that should be the position of the vertex of the parabola. So if when x was -1, you know, this is our vertex. So then for my second point, I'm just going to let x be 0. I just went to the right or the left. I just went to the side by 1 unit. So when x is 0, let me see, 0 plus 1 is 1, squared is 1, times -3 is -3, plus 4 is going to be a +1. So it should be at the point 0, 1. Okay. So basically, I just plotted the vertex and then one additional point, and that was enough for us to generate the entire graph. So I'm going to go with it. So as usual, if anything isn't clear, feel free to either unmute yourself. Let me check the chat real quick. Yeah, you guys are good in the chat and the Q&A. Okay. Relaunch. Okay. Let's see. So here we're asked to begin by graphing. So the parent function here is absolute value of x. And we're trying to identify the correct graph with multiple transformations. I'll give you a hint. There are 3 transformations. Let's take like at least 30 seconds to give this one a go. Hey, Google, play. All right. So just take a moment. What do you think? Is it A, B, C, or D? Okay. So there's a vote for C. What the answer is it going to be A, B, C, or Hey, Google, pause. Stop. Hey, Google, pause. Okay. So let's see. All right. Absolute value, right? So the vertex is at the origin. First, we went right by 1. So it can't be A or D. Okay, so it looks like our choice. I'm going to go ahead and close the poll. I'll make a note. Let's see. So it can't be A or D because they didn't go right by 1. It should be upside down. So if it's B or C, it should be C by process of elimination. Okay. All right, so I'm going to relaunch the poll on this one. And I'll give some backstory here, some context. So again, this symbol is called the greatest integer function. Basically, we're going to take the greatest integer less than or equal to x. In other words, whenever we have an integer inside this function, then we just take the integer itself. Whenever we get a decimal or a fraction between 2 integers, then this is going to collapse to the integer to the left, right? So you're always asking yourself, when you're taking the greatest integer of a number, is that number between 2 integers? If it is, it's going to collapse to the integer to the left, right? Okay. And so we call this a step function because the final graph typically looks like the stairs on the staircase, the steps on the staircase. And usually it's like the origin is a filled in dark circle, and then it's a segment going off to the right. When it reaches 1, there's an open circle. Then it jumps up to the point 1, 1, and it's a closed circle there. Then you repeat the process, in either direction or whatever. So here we have that -1 on the inside, right? So we can kind of track that point on the origin. If we subtract 1 on the inside, it should move it to the right by 1. Let's see. So the only ones that move to the right by 1 are A and D. It shouldn't be B or C. I'm going to go ahead and close the poll on this one. This one's a little bit tricky, right? And then multiplying the outside by a factor of 2 is going to cause a vertical stretch. So it should get wider vertically. So the only one that went right by 1 and stretched vertically by a factor of 2 is B. Okay. All right, so we're already halfway. Plenty of time to spare. Write the function whose graph is given but shifted left by 7 units, okay? So I'm going to start. The parent function here is x cubed. I'm going to write x cubed, but I'm going to put the x inside the parentheses. So x to the power of 3, okay? Now, if we're shifting left 7 units, that means we need to do an inside manipulation. Left would be in the negative x direction, so to capture that, we have to put it as +7 on the inside. Okay, and I think that's it. Okay, let me relaunch the poll. Write an equation for a function whose graph is given. It's x squared, but it's upside down, shifted right 7 units and up 4 units. Take a moment just to see what you think. Hey, Google, play. What do you think? What's the time? Let's go like 15 more seconds. Hey, Google, pause. Hey, Google, pause. I could do that. Okay. Oh, so let's talk about this one, right? I might have to give you guys some more work. That's how y'all are making me feel. Yeah, I might have to give you some more work. Let's see, because you're not saying anything, so I don't think you know anything. I don't know. Could be lazy. I don't know. Could just be whatever. Let me see. So here, right? X squared. It's upside down, so that means we multiply the outside by a negative, but I think all of these capture a negative. It says shifted to the right by 7, right? If we're going to the right by 7, that's the positive x, so we need to subtract 7 on the inside. So it could be B or C, and then up by 4, so it should be B, right? So let's just go with B, okay? All right, so write an equation for a function whose graph fits the description given below. We have this graph is shifted 3 units left, stretched vertically by a factor of 2. Okay, so before we do all of that, the parent function here is x cubed, right? So what I'm going to do, I'm going to start with x cubed like this with the x in the parentheses. It says it shifted 3 units left. So that's 3 units in the negative x direction. We capture that by saying +3 on the inside. It says it's stretched vertically by a factor of 2, so that's the outside manipulation. We multiply by 2. Reflect in the y-axis, so that's going to flip horizontally. So that means, so what I'm going to do, I'm just going to replace x with negative x. And then shift it 5 units up. Okay, I'm going to go with this. I'm going to go with this. Okay. All right, I'm gonna launch the poll on this one, relaunch. And I might do a quick draw, so kind of wait until somebody goes for it. Let me see. So the original function is given, and we added 4 on the outside, right? We added 4 on the outside. So how does that affect the graph, right? One suggestion is you can track the origin, that point that's at the origin. By now, you should know what adding 4 on the outside does, right? So just take a moment. Hey, Google, play. All right, I'll talk about this one. This is a little bit interesting. Hey, Google, stop. Hey, Google, stop. So this one has multiple transformations in one go. I just kind of submitted the other ones because they're kind of repetitive. The original function is given. We have 1, 2, 3, 4 transformations in one go. So again, the recommendation is to work our way from the inside to the out. What I'm going to do is I'm going to track that point that's at the origin, right? Just to kind of keep sense of it. So if we say -1 on the inside, that should go to the right by 1. I think all of these go to the right by 1, so that doesn't help us. Then we multiply the outside by 1/2. That should cause a vertical compression by 1/2. So that eliminates A, because A does not look like it was smushed vertically. Then we multiply the outside by a negative, so it should flip vertically. So it should be upside down. So now A and D are out of the question. Okay. And then up 3, the only one that went up 3 is B. So I'm going to go with B. Okay. Yeah, let's talk about this one. So we'll go like this. So let F be the function that associates the employee number X of each employee of a corporation with his or her annual salary F of X in dollars. Suppose each employee was awarded a 500 across the board raise and an additional 3% of his or her increased salary. Write a function P of X to describe the new salary. So we're going to start with the old salary, which is F of X. Okay. And then it said a flat increase of their salary of 500. So we're going to say plus 500. And then it says an additional 3% of his increased salary. So we're going to take this new salary and increase it by an additional 3%. What's shown on the screen right now is 100% and plus 3%. So we need to finish with 103%. So one way we can go about doing this is multiply all of this by 1.03, and we need parentheses. Okay. I'm going to keep taking some notes here. Give me just a moment. Ho, ho, ho. Okay. Oh, well, that's supposed to be 1.03. Let me go ahead and put the right thing so I'm not. So then we just need to simplify this. So we're going to distribute the 1.03. 1.03. That's okay. I think I'm going to make it. Let me put it in low power mode. I could plug it up. All right. So if we distribute the 1.03 times f of x, now we need to say 1.03 times 500. So basically we need to add 3% of 500 to this. 10% would be 50. 1% would be 5. So then 3% would be 15. So the final result would be plus 515. Okay. We're going to get rid of all of this. Go with that. Okay, we're almost there. So maybe we'll get out of here a little bit early. Okay, in the given graph, the temperature of a home is given as a function of time. Oh, where's the rest of it? Okay. At what temperature is the thermostat set during the daytime hours, right? So daytime is like that top plateau. Let me see, if that's 72 and that's 76, halfway would be 74. So it's slightly below halfway, so I'm going to put 73. 73. The thermostat is set to how many degrees overnight? It looks like it's set to 60. Look like it's on the line. I'm gonna if it's not 60, then it'll be 61. So if it says they reprogrammed the thermostat to be T of T minus 4. That minus 4 is on the outside of our base function, so that's going to lower the temperature by 4 degrees. Okay. So the whole thing should drop by 4. If that's a 71, 67 for that top plateau, which is only captured by D. Okay. They added a 3 on the inside, right? So that's going to move it to the left by 3, which is going to make the change happen 3 hours earlier. 3 hours earlier, just this one. So shift it to the left by 3. If that's what? 8, 10. So that's a 10. So then it should go down to about 7. I think it's B. B is the only one that's been moved to the left by 3. Oh, that was 20. All right, guys. So that was record time. I didn't finish nowhere near this earlier than the other groups. Are there any? So we did get to at least the end of this this section. Are there any burning questions? I think I'm gonna let you guys go. Okay. So if there aren't any burning questions, we're gonna go ahead and end the session here. Next week, we'll just start with the next section. That'll be the last section before exam 2. All right, guys. Take care. Have a great weekend, and we'll meet back Monday, same time, same place. Take care. Peace.